Okay, 5.5. And we're going to do 5.5. There's and then we're going to do 5.6, A and B, and one part of 5.7, which will leave us one section or one piece to do next time. So anyway, 5.5 is using the product rule. And the product rule is based on if I had 7x times 3x squared. We kind of did this already in 5.1 or 5.2a, I think it was, where we had some multiplication stuff that we need to do. Well, we go back and use, of course, the product rule of exponents, and that product rule of exponents says, what do I do? If I'm going to multiply two exponents together, what do I do?
Times 7 times 3, which is 20.
So we multiply, whoops, 21, not 27.
And then you add the exponents.
Because the product rule says add them. So 1 plus 2 is x to the third. So basically all I'm doing is taking the numerical parts, multiplying those, coming up with my value, then taking the two exponent parts and adding those together to end up getting my value that I would happen to have. So if I had 3x to the third y to the 7th times a negative 2x to the 4th y to the 3rd, what would I come up with for an answer?
You use the FOIL method.
Well, not FOIL. Don't get FOIL mixed up with this. This is a monomial times a monomial.
Okay.
So to do FOILing, you got to have binomials. So this one's just two monomials. So basically, same thing as we did up above. 3 times negative 2, negative 6. X to the third, x to the 4th is x to the 7th. Y to the 7th and y to the 3rd is y to the 10th. And we are done.
So you wouldn't distribute the y and the x. Let's say, so you just times the y to the y's and the x to the x?
Yes.
Okay, that's why I was.
Because all you're doing with your multiplication right now is just multiplying numbers, multiplying the x part, and multiplying the y part.
Okay.
There's nothing real complicated about it because all you're doing is matching like stuff together.
That's probably why I was having trouble.
That could be because you're jumping ahead. Yeah, we will get to those, but right now these are the ones. So then if I have a monomial times a binomial, so that would look like 3x times 2x plus 4x squared. If I have this part, then you're going to do your distribution. You're going to take 3x times 2x and 3x times 4x squared. So you kind of got some double duty multiplication here. So if that's all I had,
6x squared.
Then that's what I have. And so because the sign here is a positive, 3 times a positive 4 is going to be a positive 12. X and an x squared is x cubed. We good with that part?
Yes.
Okay. And so as you do those monomials and times a binomial, you just got to watch where your pieces are at. So if I have a negative 3x squared y squared times 2x squared plus 3xy plus 7y, what will I end up with this one? So all I'm doing is again taking this, timesing it by the first piece. So what does that give me?
That gives you negative 6x to the 4th y squared.
Yes. And if you don't have something to multiply it by, you just simply, whoops, to the 4th, you just simply bring whatever it is along and put it at the tail end, because it still has to be there. It's not like it disappears and goes away.
You just times it onto the problem, and if there is y, then you still have to add the exponents.
Yes. Yep. So now what happens? If I cross this one off, now I got to multiply this times this. So negative 3 times a positive 3?
Negative 9. X squared y to the 3rd.
X cubed y to the 3rd. Yes. And then finally the very last one, Negative 3 times a positive 7 is a negative 21.
X squared.
Yes. No x's here, so I just bring it along. Y squared. Y to the third. Yes. Okay. So far, so good?
Good.
We could see what we did with that one? Okay. Now in chapter 6, just so we start thinking chapter 6, because chapter 6 we're going to reverse this. We're going to look at this piece down here and say what could we take out of it. And when we do that, we're going to come back with this piece at the beginning. Again, I'm not going to get into that today, but you're going to reverse it and you're going to come back out with this piece and this piece. So we're going to pull stuff back apart to see what we can get out of those things when we're doing those. So let's see what else we got in here. X times 8x squared minus 3x plus 2. What do we get out of this one?
8x cubed. 3x minus 3x squared plus 2x.
Mm-hmm. Yep. So all I did was to take this x, which is to the first power, and multiply it by each piece. If you don't have a number out in front, there's a 1 there. So I know I have a 1. So that 1 times 8 is 8. And x times x squared is x cubed. And then I multiplied it by each other of the other pieces that were in there. So I come up with my answer. Now, in this section, they also give you a binomial multiplied by a binomial. But they don't talk about FOIL, and we're going to talk about FOIL at the same time. FOIL is actually brought up in 5.6 is where, in 5.6a is where they FOIL. I'm not quite certain why Hawks did this and broke it apart, but you have it in 5.6a and you also have it in 5.5. So binomials look like x plus 2 times x plus 3. So if that's a binomial, I have my two pieces in there. Now what does FOIL mean? Have I heard FOIL before?
Yes.
From high school, maybe?
First, outer, inner, last.
Yes. The F from FOIL means the first terms multiplied together. So if I take the first terms, x times x, what does that give me?
X squared.
Yep. O stands for the outside
Which would be 3.
terms multiplied together. What's that going to equal? So
Yes.
outside means I multiplied the first terms, then I'm going to multiply those two. So x times 3.
3x.
I is the inside terms multiplied together. So now I'm going to multiply 2 times x. That's going to give me
2x.
2x. And finally, L is the last terms.
Which is going to be 6.
And so then I'm going to multiply 2 times 3, and 2 times 3 is 6. And once I do all of that, keeping track of these were all pluses in here, I now have x squared plus 3x plus 2x plus 6. But if you go back and look at this, and we go back to 5.4 where we added like terms, notice 3x and 2x match. So I'm really left with x squared plus 5x plus 6, and I'm all done. Okay? So keep that in mind when you're doing this foiling, that you got to keep your signs along with your numbers. So don't forget your signs in there and coming up with what those happen to be for those. So let's do some more of these foiling ones. And again, that is your 5.6a as well as your 5.5, and you can end up using it with your 5.5 things as well. So how about this one? 4x minus 2 times 3x plus 1. What will we end up getting out of this whole thing? So if I FOIL it, what happens? 4x times 3x is?
1x squared.
Then 4x times 1?
4x.
Then negative 2 times 3x.
Negative 6x.
And negative 2 times 1.
Negative 2. And then you have
Then put these two together in the middle, and I get 12x squared minus 2x minus 2. And that would be my answer. Now again, in chapter 6, we're going to tear this back apart and turn it into two binomials. So you got some combinations of stuff that you got to do there, and getting that stuff back to work with whatever part you got to work with for those. So that's a key thing, so make sure that you get the idea down with those. How about negative 3x minus 2 times a negative 4x plus 1? What do we get? Work it out. See what comes out of that one. A lot of sign change stuff happening in this thing. And if you're having problems with that, treat it as if you have just a plain monomial out here. Take that negative 2 out of there and multiply it by each piece. And then do the opposite of taking the 3x out if you're having a problem on getting those things to multiply correctly. 3x times a negative, or negative 3x times a positive 1. Negative 2. Negative 2 times 1. Then piece your stuff together. And you get that for an answer. Okay or not okay? What do you think?
I've got this done 100%.
You got down 100%? About the rest of you. We can do some more. We need to do some more. Maybe we do need to do some more. How about if we have 5x minus 2 times 7x plus 3. What happens to that one? See what we get for an answer to this thing. So that's what you should have. Multiply everything out correctly. Foiling again, first term times first term is 35x squared. The outside terms, 5x times 3 is 15x. Inside is a negative 14x. And finally last, negative 2 times 3 is negative 6. Put my middles together, and I get 35x squared plus x minus 6. Okay or not okay?
Okay.
The last thing that they put in 5.5 is a binomial times a trinomial. So that might look like x plus 2 times 3x squared plus 2x plus 1. Now when you have this, your easiest thing to do is, of course, multiply the first term by everybody. So x times 3x squared is 3x squared. x times 2x, oh this should be a cube, sorry. X times 2x is a plus 2x squared. We okay with that part?
Yep.
And x times 1 is x. Then go through and multiply 2, and if you want, instead of doing it in a big long line, you can take your 2 times your 3x squared, write that underneath your other x squared. 2 times 2x is 4x. 2 times 1 is 2. And now because I've distributed everything in there, now I can line that up and add up my pieces that match. So 3x cubed, 2x squared, and 6x squared is 8x squared. 1x and 4x is 5x plus 2, and you end up with that for your final answer. Are we okay or not okay? Again, that distribution. You could also do the same thing with this one down here if you wanted to. You can write 35x squared plus 15x for your first multiplication. Then line your 14x and your minus 6 underneath. And then you got everything lined up so you can see what happens with those. And so then you get 35x squared plus x minus 6. Same thing as we did up here when we lined up our stuff with those. Another one of those. 3x minus 4 times 2x squared minus 8x minus 4. See what happens with that one. Well, if you double check it, 3x times 2x squared is 3 times 2 is 6. X times x squared is x cubed. 3 times negative 8 is a negative 24. X times x is x squared. 3 times a negative 4 is a negative 12. And the x comes along because the 4 didn't have an x. Then negative 4 times a positive 2 is a negative 8. And the x squared comes along. Negative 4 times a negative 8 is a positive 32, and the x comes along. And last, negative 4 times a negative 4 is a positive 16. And then combine stuff. The x cubes don't combine with anybody. Negative 24 and a negative 8 is now negative 32. X squareds are my label, so don't, that's the other piece that you guys start making mistakes on. And making that square in there, it's not. It's just an x, to the 4th power, it's just an x squared. And last, negative 12 and a positive 32 is plus 20, and the x, and then the 16 comes along. And so that becomes your answer for those. So that's a binomial times a trinomial. And the last piece, 5.5, is a trinomial times a trinomial. So something like x squared plus 3x minus 7 times 2x squared minus 3x plus 9. If that's the piece I have, another method you can use is to write these above each other. Realizing that you're multiplying, start on the left and work your way back across. Take 2x squared times x squared gives me 2x to the 4th. 2x squared times 3x is 6x cubed.
But it's minus 6, isn't it? Negative and a positive.
No, it's a positive 2 times 3.
Oh,
It's positive
okay, I
6.
see what you're doing. I thought you were going straight.
Nope. Just taking the first term and multiplying it by each piece.
Okay.
Okay? 2x squared times a negative 7 is a negative 14x squared. Then go to my middle. Negative 3x times x is a negative 3x cubed. Lining it underneath where it belongs. Negative 3 times a positive 3 is a negative 9x squared. Negative 3x times a negative 7 is a positive 21x. And then finally go to the 9. 9 times x squared is 9x squared. 9 times 3 is a positive 27x. And finally, 9 times a negative 7 is negative 63. Now if I line them all up underneath each other, instead of having that big long line, you can do a big long line if you want, but it just seems to make your math a little easier because you've got your cubes under each other. So positive 6 and a negative 3 is a plus 3. The next column, a negative 14, a negative 9, and a positive 9. Well, the negative 9 and positive 9 cancel each other out, so I have a negative 14. And then 21 plus 27 is 48x. And finally, just bring down the negative 63 and you are done.
Now, do you have to put them in descending order to do it that way?
Well, you should. They'll always end up in descending order. If you line them up like this, they'll always be in descending order. And we need descending order when we get to division. But that will be on Wednesday when we'll get into the full longer division where we're going to have everything in descending order. But yeah, it will automatically come out in descending order. One more like that, then we'll finish up 5.5. So if you have 2x squared plus 3x minus 7 times 6x squared minus 2x minus 4, what will I get? And again, if you don't want to line them underneath each other like I did up here to do your multiplication, just do the same thing here. Multiply that times each piece, write that down, go to your next piece, multiply it through, line it underneath it, do your third one, and line it up underneath, and you'll have them all in where they're supposed to go for your answer. So 2x squared times 6x squared is 12 what? 12x to the 4th, right? 2x squared times a negative 2 is a negative 4x to the 3rd. 2x squared times a negative 4 is a negative 8x squared. Cover that one up. Now I got to move to my 3. 3x times 6x squared is 18x cubed. 3x times a negative 2 is a negative 6x squared. Positive 3 times a negative 4, negative 12x. We good so far? Last, move my finger over again. Negative 7 times 6x squared is a negative 42x squared. Negative 7 times a negative 2 is a plus 14x. And last, negative 7 times a negative 4 is a plus 28. So working your way through, it's just, once you start breaking it apart, it's like having a monomial times every single piece. until you get to where you've got all of your pieces multiplied. So 12x to the 4th. 4 from 18 leaves me with a positive 14x cubed. All of this added together, 42 and 8 is 50, plus 6 is a negative 56x squared. 12 from 14 is a positive 2x. And then plus 28 at the tail end. Yes?
In one of the chapters, they threw another one of those problems out where you don't see anywhere else. Just one-time problem.
Yeah?
It's a word problem. A square is 4 inches on each side. A small square x inches.
We're heading there right now. We're going to head there. So hang on a minute. Yeah. Yeah. No, you will run across those. You probably didn't run across that in your certify, huh?
Just one.
Just one? Yeah. Yeah, we'll talk about that in a second here when we get into 5.6a. We okay with this part? We good with 5.5? Okay. And 5.6a we already talked about, because in 5.6a that's where they introduce FOIL. But again, we know that's the first terms multiplied, the outside multiplied, the inside multiplied, and finally the last multiplied, and combine your middle terms to end up getting that solution in there. And so that ends up being the thing with FOIL from that. And again, that was where you had a binomial and you just multiplied 2 times 3x is 6x squared. 2 times a negative 2 is a negative 4x. 1 times 3 is a positive 3x. And 1 times a negative 2 is a negative 2. And we just put our middle pieces together. And we got our answer. Okay? And so that whole section in 5.6a is all foiling. They do add things such as x cubed minus 4 and 2x cubed plus 3. Now the only difference with these guys is that when you FOIL, x cubed times 2x cubed is going to give me what? What do I get if I multiply those two together? Yes, 2x to the 6th. This times 3 is a plus 3x cubed. 4 times 2x cubed is a minus 8x cubed. And last, 4 times 3, negative 4 times 3 is negative 12. So the only difference is that you have a little more adding to do with your value, or your variables, and what happens to come out of that. So yeah, you do have that type of a thing. Now, the one that Scott's talking about is where they will give you all the verbal information about a shape, and what they're talking about with that verbal explanation, and I don't have all my wording with this, but it involves a rectangle, and what they do, and I think this is what you were talking about, right? Am I right? Am I right? Okay. And they'll give you a rectangle, and they'll tell you that one side measures 12. So this whole side measures a length of 12. Okay? And then they tell you that each of these pieces that they've cut out have sides of x. So what does my area, so now we want to know area of a square. So what's the area of a square's formula?
12 times 12.
What was that again?
12 times 12.
12 times 12, or a side times a side, or you could still get by with length times width, or a side squared. So in this case, I'm going to have 12 times 12, because that's going to be my size of this thing, which is 144. Okay? But these corners are all subtracted from that. How do I know what size this corner is? Well, x times x is x squared. So this is an x squared. What's this one? What's this one? What's this one? So what do I got to do? Well, I got to take 144 and minus 1, 2, 3, 4 of those. And that's my answer. Okay? because all they're doing is they're saying whatever this side happens to be and taking away 4 of those little squares in the corner. Okay, does that make sense? Yeah, that's what they're asking you to do. So if you get a word problem in here, so you get a story problem that's connected with this, it's the rectangle one. I think they draw this in there, don't they? Yeah. They give you a drawing of what your rectangle happens to, your square in this case happens to look like. If it were a rectangle that they did the exact same thing with, they might say this side is 4 and this side is 12, and then have the chopped out corners that are x by x. They always give you square corners that they take out. So in this case, it's 4 times 12 minus 4x squared. So my answer is really 48 minus 4x squared would be what I'd get for that. Okay? But yeah, I was heading there. You're just ahead of me. That's all. Yeah. So I was heading in that direction. Anything else on this stuff with my foiling things? Are we all good with that? Okay. Again, foiling, you want to make sure that you do that multiplication out. Don't take shortcuts with it. Make sure you do multiply them. Because again, when we get in chapter 6, we're going to come back to this piece from this. I'll give you the answer, but we need to take it back and come up with our 2 binomials that are connected with that. 5.6 B. B has special products. And what they mean by special products is we still have these binomial things, but we might have a binomial that looks like x plus 6 times x plus 6. Now, you may not notice and say it looks any different than anything we've been doing, but it is different. What do you notice about it? They're the same. Yeah, these are the same. They're the same. So because they're the same, what does it do for us? Well, the rule is that I take x times x is x squared, just like we normally FOIL. And then I get plus 6x. And then I get 6 times x is another 6x. And 6 times 6 is 36. So what I find is 6 plus 6 is 12x plus 36. Is there's a shortcut. And again, if you don't pick up on the shortcut, it's going to save you, actually if you did pick up on the shortcut, it would save you a lot of time in intermediate algebra, because we run across these guys all the time in there, these perfect combinations of 2 binomials that are exactly the same that are multiplied by each other. The shortcut is square the first part, so square x gives me x squared. Square the last part, or square the last terms. So 6 times 6 is 36. And the middle is the first term times the last term doubled. Doubled means I'm going to multiply by 2. So x times 6 is 6x doubled. 6x times 2. And that's where they come up with that at. So if you can remember that, it saves you from foiling it, because I don't need to foil it. X times x is x squared. 6 squared is 36. X times 6 is 6 doubled. Gives me my middle term in there. So if you can remember that about those, that's one thing. Sometimes you see these also as x plus 6 with just a square outside of it. And the mistake you guys all make, and my intermediate algebra people make the same mistake, even though I tell them over and over and over and over, you can't do that. You want to distribute the x, or this 2 by each piece. I cannot do that because of the plus sign in there. Also, I could not do that if it were a subtraction sign. This 2 actually means I want to see x plus 6 2 times. Or I want to see x minus 6 2 times. And so you have to write those out or use the shortcut. Square the first, square the last. First term times last term, x times a negative 6 is a negative 6 doubled is a negative 12x, and you would be done with it. But you can still FOIL if you can't remember that part. So it's kind of knowing that you can do this shortcut stuff, but you gotta see it twice. Don't distribute the 2 into square pieces. Will not be right. Hawks will definitely tell you it's not right. So would I, because you can't end up taking those things and squaring them. So you want to see those things twice. What would we get for this one? 2x minus 3 squared. If I had that one. One more time. I think that's what you're saying. Write it out, right? Okay. What would it equal? Shortcut, square this. 4x squared. Square the 3. Okay. And 2x times negative 3. Negative 6 doubled. What's a negative 6 doubled? Yep. And so your answer comes out to be x to the 4th minus 12x plus 9. If you FOIL it, 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2 is another negative 6x. Negative 3 times negative 3 is a plus 9. It saved me a bit of work if I can get that down. Of square the first, square the last, then multiply the 2 and double it to get your answer. Okay. The last of the specials is where they give you x minus 2 times x plus 2. That's 2 binomials with the same variable with opposite numbers. What happens to this one? X times x, if I FOIL it, is x squared. X times 2x, or times 2 is positive 2x. Negative 2 times x. And a negative 2 times a positive 2. And then when I stick it all together, my middle disappears. And so I'm just left with x squared minus 4. And that is a difference of squares. In chapter 6, when we see this, we need to start thinking that, because each of the n values are perfect squares, meaning x times x and 2 times 2 to give me 4, but because there's no middle term, I just have opposite signs in there. And again, we'll talk about more of that in chapter 6, but at least getting you thinking about the ideas of what happens to these. So what if you had x squared minus 3 times x squared plus 3? What would I get out of that one? X to the 4th minus 9, and you are done. So if you recognize that, then you're done with it. In intermediate algebra, we use this too, because in intermediate algebra, these two are called conjugates of each other because they make the middle term disappear. And when we get into radicals and that type of stuff, when we've got to make something go away, we use this principle. So if I got that piece and I've got your differences in there, then that's what happens with that one. Okay, another one. How about if you had 2xy minus 3 times 2xy plus 3? What would I get with that one? 4x squared y squared, yes, minus 9, and you're done. Okay, shortcuts with those. So if you notice that they're the same outside of signs are different, I didn't have to go through and do all that foiling stuff with it. How about this one? 9x minus y squared. What happens with it? What was that again? Yeah, so we got to write it out twice. Then we need to FOIL stuff, right? 9x times 9x is 81x squared. 9x times a negative y? Negative y times 9x. And finally, negative y times a negative y is a plus y squared. So my answer is 81x squared minus 18xy plus y squared. So you've got x's and y's in that one. So you got a lot of distribution type stuff happening in there. So you want to make sure that you get those things going on so that we can work through our pieces with that and get our values. One last one, and we'll stop at this section, for this section anyway. 4x plus 8y times 4x plus 8y. What will I get out of that one? 16x squared. What's the rest?
Plus 8y squared.
2 times 8y.
2 times just 8y?
Plus, no, 2 times 8y times 4x, because you've got a and b. 2 times
Okay.
a and b.
So 4 times 8 is times 2
Plus 32xy.
if you do it separately, right?
Yes.
Yes, because I got the same thing here as I got out there. And then finally,
Okay, where are we? Yeah, 8 times 8 is 64y squared.
perfect. But then these two got to get put together. So 16x squared plus 64, xy plus 64y squared. And that would be my values that I'd have for that. Okay? Now, if you remember this middle piece, notice what happened? It got doubled.
You can just add the
4
three.
times 8 is 32, xy, double it, gave me the 64. Okay?
When I'm doing mine, I do mine the x squared plus or minus the 2 times the a and the b plus the a squared. Am I doing it right?
Yeah.
I still get the same
You're
right
still
answer.
foiling. Yep.
Okay.
Yep.
That's all.
Yep. You are still doing your foiling stuff with that. Yep. All right. So that is that piece. So let's. 5.7a is dividing by a monomial. And it's kind of like what we did in 5.1 and 5.2a. It's just they don't get quite as difficult. So use methods from 5.1 and 5.2a. Because basically what you're going to do is reduce each part of the problems. So dividing by a monomial looks like 3x squared plus 2x minus 7 divided by 2x. So I have a trinomial on top because it's got 3 parts. I have a monomial on the bottom. And so how I solve this is to take each part and put that same monomial under those parts. So that what I end up with when I'm done with this is I basically end up with 3 problems. I end up with 3x squared over 2x, 2x over 2x, and a negative 7 over 2x. So if I treat this one as if it's its own separate problem, what comes out of it? Well, I cannot reduce the 3 and the 2. You okay with that part? Can't reduce them. X squared and x, because I'm dividing, what has to happen? Well, 2 take away 1 leaves me x in the numerator. Second piece of my problem, 2x over 2x, what happens to that? They cancel, right? The 2's cancel, leave me with a 1. The x cancels, leaves me with a 1, so I just have 1 in the middle. And then finally, my last piece of my problem, can I do anything with that piece? Can I do anything with 7 or the 2x? Nope. So this becomes my answer. That becomes what I would type into Hawks and what I would end up putting in for that value and what would end up coming with that. So let's take a look at another one. So what I did with this one, to recap it, is I just took that binomial, put it under each piece of my trinomial, treated each section as its own separate problem, because now they look like that stuff we had in 5.1, where we started working with our properties on our exponents and reduced each one to see what I came up with. So here's another one. So if we have 3x cubed plus 6x squared minus 9x all over 3x, what will come out of this one? So each piece gets a 3x under it. And then I look at each one and see if it can be reduced. Can I reduce that part? What does that come out to be? X squared. Not that one. 2x plus 2x. And finally the last one, negative 3. And you're done. Okay? So, straightforward enough. What happens with those two? How about this one? 8x squared plus 14x plus 1 divided by 2x. So it's 8x squared over 2x plus 14x over 2x plus 1 over 2x. So 4x was the first one. What's the second one? Plus 7. And last one? Can't do anything with it because there isn't anything that cancels, so I just end up with 1 over 2x. Yep, so I end up with 1 over 2x, and that would be my answer. Okay? Not bad, hey? Okay. Another one of those might be something like 8x squared plus 8x plus 1 all over a negative 8x. What's going to go on with this one? Again, separate them out. And reduce if you can. Does stuff reduce? What kind of x? Yes. Don't forget, when you divide 8 by a negative 8, it still leaves a negative 1 in there. So you got to have a negative out in front. 8 divided by a negative 8 is still a negative 1. And x, what happens to them? Gone, gone. And what about this last piece? Minus 1 over 8x. Because remember, Hawks does not like negatives in the denominators. So you would change your sign. Positive 1 divided by negative 8 makes it negative. And the x doesn't cancel anything. No, it's just an x. Yeah, just an x is what you'd have in there. And this one, they give you sometimes a larger one, 9x to the 4th plus 3x squared plus 9x cubed plus 3, yep, all over 3x cubed. What comes out of that whole thing? All it means is I've got one more division stuff to do. So I got 9x to the 4th over 3x cubed plus 3x squared over 3x cubed plus 9x cubed over 3x cubed plus 3 over 3x cubed. So what do I get? 3x plus where? Top or bottom? 3's cancel. X squared over x cubed. Be careful. Where is it at? It's in the, yeah, it's a negative exponent, so it's got to go to the bottom. Be real careful with that, making sure that you get a fraction in here, not just plain old x. And what's about the next one? It's a 3. And finally, plus what was it? Oh, where's it at? 1 over x cubed. When you say x cubed, I'm thinking you mean x cubed on the top. Is that what I think you thought? Yeah.
1 over.
Because these 3's cancel, they're equal to 1. Because this is in the denominator, I have to have a numerator. So I have to have a 1 in the top. Okay? All right. These are okay? Or you want one more?
I'll give you a couple more.
2 more? Okay. We can do that. 6x to the 4th plus 3x plus 2x squared minus 1 all over 2x squared. Do we have an answer for this thing? 3x squared. 3x over 2? Yeah, what about the rest of you? You like that or not?
Minus 1 over 2x squared.
So where does the x belong?
On the top.
This is a 1, this is a 2. Remember, we subtract it, it's got to go down here, okay? When you said 3x over 2, you got your x in the wrong location. This is a separate problem, just like it is. So when you do this, I can't do anything with the 3 and the 2, but these x's are different. If you brought the 2 up here, you get a negative. X to the negative first. Can't have a negative exponent, so it's got to go to the bottom. What about the next one?
Minus 1
what happens to that?
That disappeared.
It becomes a 1 though. It doesn't disappear. It just cancels to 1s. So don't forget the 1 in there. It's got to be there because it is really part of your answer. Now you can write the last piece just as it is. But don't forget the 1. If they cancel out altogether, there is a 1 there. So don't make that thing disappear. All right, another one. How about if we have 7x to the third plus 14x squared minus 28x to the fifth plus 2 all over 7x squared. What happens to that thing? This is a 2. And you may think you're doing a shortcut by maybe not writing all of these out, but it is so easy to miss something. Take the extra time to write them out. It does not save you anything in Hawks if you miss something, because you got to go back and practice it some more, or you got to go back and recertify, or things on that order. So be real careful making sure that you do your steps. So what happens with the first one? I just have an x. And the second one? Plus 2, because the x squareds cancel. The third one? Minus, yes. And then the last one?
2 over 7x squared.
Perfect. Yep. So you got some cancellation stuff. Hopefully that helped you out. Did it help? Okay. All right. So that takes care of that section.